Hello everyone, this is Direwolf20 and welcome to episode 74 of Direwolf 20s. Oh, that's not what I want. Come here, you. Server play series. I'm doing one more thing. I know I said I was kind of done with this, but there's one more thing I want to do, and it's going to happen now. And I'm excited about it because it's going to mean the end of something that's been kind of annoying. So I also need my wrench. I know I was forgetting something. I knew I was forgetting something. Where is the... Oh, screwdriver. That's what I need. Cool. This thing flickers because we're not using as much power as we are producing, typically. So it winds up just flickering on and off, and it's really annoying me because it causes explosions and all kinds of problems and just headaches is what it causes. Lots and lots of headaches. Oh, looks like we have a net gain of distilled water. That's good to know. I just found that out. I just tested. So I've rewired downstairs a little bit so that we have stuff going that way, and that's all well and good. Cool. This is coming out, so this MFSU is facing down. As you can see, it's outputting down. And this one is outputting to the back. And this thermoelectric generator is feeding into this MFSU. So we're outputting 2048 plus 32 for a grand total of 2076. Nice. And out, we're doing fluctuating amounts. It's the recycler that's running right now. I turned off my mass fab, and we're filling up the drawer here with scrap. Cool. So that's that. So what I want to do is basically say this will emit if empty, and this will emit if full. And what I'd like to do is make it, let's see, is that what I want? Emit if empty, emit if full. So, yes. Yes, well, I think. So full will turn it off. And when the one on the right is totally empty, it'll kick on the reactor. That sounds about right. Yeah, that should be good. So that's what I want. So this one will emit if full. So we're going to do, basically, I keep doing the same circuit, but it's pretty much the circuit that I want all the time, right? Like maybe there's a better way to go, but this is the circuit I want, so why not? It's going to be an RS NOR latch. Boom and boom. And we're going to read from, so you are not empty or full. Let's see. So this will be emit if full. Let's see, I might want to change this up a little bit. All right, guys, I think I've got this. Let's see if I'm right. So this will emit if partially filled, which means, I think if partially filled or empty. I want if partially filled or full. I mean, I guess I could do emit if. So let's do that. And that. So you shouldn't be active now. So emit if full. We want this one to actually be emit if empty, right? So if it's empty, it'll emit a redstone signal and turn this on. And then when this is full, it'll emit a redstone signal and flip this bit. So that should work. So basically, this should run until empty. Hopefully empty will count. So let's see if we can empty this thing real quick. So all we gotta do is drain some of the scrap. So we're just testing here real quick. So basically what I want to do is toggle it on and burn through both sets of power, right? So I wouldn't mind having a little bit of a buffer. You know, I could have this just be if partially full. You know what I'll do? Yeah. If partially full. And then I could have a manual lever if I want to force it on. So, nah, I still want this to be empty. Yeah. So wait, why are you, okay, yeah, that's right. Wait, this is backwards. Why am I derping so hard? So emit if empty. All right, I think I got it. So this one, emit if empty. This one, emit if full. So let's set this right now to emit if partially full. Yeah, there we go, empty, boom. So that should stop it, right? So when it's full, it'll stop, right? And then when it's empty, it'll emit a redstone signal turning this off. And it's just reversed from the way it normally is, allowing this to turn on, activating the redstone signal. So that should work, right? So empty, turn on, full, turn off. That's how it should go. So once this empties out, our reactor should turn on. And then once this is full, our reactor should turn off. Let's see if that is what happens. All right, guys, we're down to close to 2 million here. EU stored. So, like I said, when this is empty, it emits a redstone signal, turning off the torch, which will allow this torch to turn on, which will turn on this guy, keeping this lit, right? So your basic RS NOR latch, in theory. We'll see how right I am. And then when full, the reverse will happen. So that should be good. So 800K, 700K, shortly here, we should see this flip off and trigger everything. Let's just see. 200, 100. All right, in theory, go. Yay! Everything on. Nice. That's what I wanted to see. Cool. Now to confirm this theory, I'm going to turn off my UU matter, and I'm going to wait, hopefully a few minutes here, and hopefully I'll be able to get to catch this thing filling up, but it might be a while, so we'll be back. All right, guys. Looks like we're pretty close. I've just been kind of AFK for a while and checking back every now and then, and it looks like we're at a point now where we're good to go. So that's cool. So in a minute here, we should see this switch off the reactors. So that's cool. And if I'm right, then we've got a perfectly functional system and no more flickering reactor. Because every time I came down here, there were typically explosions, and it was annoying me. Oh, cool. It just did it. Nice. So it's full. It flickered off. Now the reactors are stopped pumping hot coolant in, and this won't run again until this MFSU completely empties out. Neat, right? I like it. Okay, cool. So let's take a look at some stuff. There is a new mod on the server that I wouldn't mind checking out. And it's very new, like super new. So we're going to play with it a little bit and see how it functions. And I'm going to be honest with you, I haven't done a lot with it yet. So let's figure it out. So at RF control, maybe? RFTools, can I just do at control? Hey, there it is. Cool. RFTools control. Nice. So there's several things here. Programmer block, card base, node, RAM chips, network cards, processor, program card, neat, RFTools control manual. That's what we're going to want. Absolutely one of these. Boom, boom, boom. So what is this model about? I don't know yet. I honestly really haven't even looked at it yet. I haven't looked at it at all. It's obviously written by the same author that does RFTools, McJady. I think, and I might be wrong, but it's like a neat little like programmer type thingy, but it's not like writing code. It's kind of more, I don't know. I think it's more like Steve's Factory Manager, to be honest with you. So let's take a look. Introduction. I'm going to read through this, and then we'll come back and check out the mod. All right, so I flipped through this book real quick. We're going to need a programmer, and we're going to need that little card thing, and then we're probably going to need a CPU core and some memory, and maybe the processor. Yeah. Okay, so let's take a look at crafting these things. So we're going to need a CPU core, 1 operation per tick, 4 RF per tick, programmer. So we're going to want a programmer. Okay, cool. I'm going to hang on to these things because I think I'm going to need them in a minute. We're going to need, I don't think we need the node yet, but we're going to need a processor. For that, we're going to need a couple card bases. So processor, check. And then we're going to need, let's see, 4 operations per tick, 16 operations per tick. Let's go with the basic one, 1 operation per tick. Or what's this one involve? So that needs so that's an upgrade from this one. Okay, cool. So I'll get the middle tier one, assuming I have 2 emeralds. Emeralds? Oh yeah, I'm good on emeralds. Nice. And diamonds. For some reason, shift click didn't work on that. I'm guessing those cards don't stack, and you know how that goes. Okay. And then the last thing I think I need is this program card. Use this item, the programmer, to write your program. Cool. I can do that. All right. And then I think there's memory that I'm going to want. So another card base. All right, we're going to need more cactus. Oh boy. We are going to need to do something about cactus automation at some point. So in a second, that should show up. Cool. And then we can get RAM. Sweet. All right, so programmer, processor. Let's start with the programmer. Cool. I like it already. So I believe this can go in this slot. Thing seems about drop opcodes here to delete them. Okay, that's cool. Clear, save, load, val. Okay, nice. So let's look at these. So these are events. So this is basically what causes your program to start. So redstone on, redstone off, repeat, signal. Okay, this probably just connects your code from one place to another. Count items external, internal, storage, eval examine item, read redstone. That's cool. Get RF in machine, get max RF in machine. Oh, that's cool. That sounds really useful. Greater than, equality. Okay, operation set redstone. Nice. Okay, so we can output redstone, wait, stop program, log message, fetch items, push items. So we can move items from one storage inventory to another. That's cool. Set variables, add, subtract, divide, multiply, modulus, and string concat. Cool. All right. So thus far, it looks like in this programming language of ours, we can actually read and write redstone, and we can read and manipulate items and inventories. So let's see about doing a basic program with just redstone. Now this program is going to be stupid. Okay, it's probably going to be something really stupid. Oh, that's cool. Look at that. Neato. I need him to, I'm thinking this is where CPU cores go. This is probably where memory goes. Oh, maybe up here. I guess it goes up there. I would have thought it would go up there. Oh, no, wait. Oh, hello. Okay, cool. No, it goes over here. That's neat. So you get 8 variables per RAM chip. I'll get more in depth with this in a minute, but hopefully we'll get this going. And then we're also going to want a capacitor. Let's just get a simple capacitor bank going. Just for now, so we can test it and figure out how this thing works. Cool. Nice. I'll let this fill up in my inventory for a minute. Okay. Good deal. So, programmer. Let's write a simple program. So we will say redstone off, side, oh that's cool, variable function, neat. Up. Okay. So redstone off on the top will cause us to operation set redstone side north. What direction is north? That way. That works for me. Like I said, a really stupid and simple program. Level 15. Sound cool? Or let's make it just for coolness factor 10. Like I said, this is the very first version of this program. So if we save this, cool. Now I can clear this, and I should be able to come in here and load this. Okay, cool. So that should be all that we need to do. So if I pop this in here, Set up item and variable. Okay, that's cool. We don't need to do that. So in theory now, if I were to get a lever, how do I make this thing run? Okay, hold on. I think I got it. Okay, hold on. So turn it on and then turn it off. Nice. And we're emitting a redstone power of 10. Cool, because that's what it did. So event redstone off means wait for a redstone signal to be on and then turn off. Gotcha. Cool. Now, can I say event redstone on? Can I have more than one event on a thing? We'll find out. Then we will want set redstone on the north side to be, I don't know what that does. Okay. I don't know if that's necessary or not. I have to look into that. We'll make it 5. How's that sound? Cool. So let's get our program card. We're going to pop it in here. We're going to hit save. And then we will put it in there. So on, nice, 5. Off. That's interesting. I guess I can't have, I'm assuming then that I can't have, or does this need to be connected here? I think it might. Save. I'm learning the mod. Error. Okay. On, off. What's your error all about? Interesting. I think I dragged them here. Okay, cool. And then save. Okay, so I'm guessing I can't have more than one input like that. So if I would want that, I would need to have 2 different program cards. Okay. That was a hunch. But that's obviously not all it can do. So let's break this thing to reset it. I would like a reset button on the UI that just completely resets everything. That's cool. All right, let's play with reading events. So instead of this, so we're gonna get rid of you. So redstone, we're gonna say when the redstone is on. Then we want to count items storage. Sweet. What's that green dot mean again? So I lied. Apparently you can have more than one, multiple events on the same card and thus multiple programs. So that's interesting. I had to figure that out then, what I was doing wrong with that one. That's neat. So I'm pretty sure the green dot here just means these are connected. So that's cool. So let's see. Item constant variable. So we can say, that's cool. Close routable. Neat. Okay, that's cool. Variable index function. Wow, complex stuff. Cool. Count items in storage. That's what we're doing, right? Eval examine item. Examine an item in a specific slot from an external inventory adjacent to the processor or a connected node. Okay, that's helpful. Reading that shift definitely helps. Count the amount of items in a storage system. Scanner. In a storage system. Got it. So that's, okay. Eval count items. Count the amount of items in a specific slot or of a certain type in an external inventory adjacent to the node. Okay, so this, items in storage, relates to the RFTools storage system. These things. Storage scanner. Boom. Okay. So we don't want to use this one. We want to use the chest guy. Count items in a slot. So let's get rid of this. And we will say inventory. Interesting that there's 2 of these, but we'll say up for now. Cool. Slot 0. Item doesn't matter. We'll let it be anything, right? And then we can write something that does the output. So log message, log a message on the processor console. Parameter message, the message. Cool. Now this guy should, result is the amount of items. So it should log it to the console. Variable, function, last string. Last string is what we get from this dude. Cool. So that should be good. So I think that's what we want. So let's try this. I'm going to put this in here. We're going to save it. And then we're going to get a chest. We're going to put the chest on top of this dude. We're going to put some amount of items in there, and then we're going to run the program. Cool. Now, how do I make you run? Redstone signal, that's right. What, did I say that had to be on a specific side? Nope, any side. Cool. So are we running? This might need to be here. Save. Now can this change? No. Okay. Interesting. Debug time, be right back. Oh hey, I got it working. Nice. Okay, I figured out how the green dots work. Cool. The green dots are not inputs, they are outputs. So this green dot outputs to the log message, right? This redstone outputs to the eval count items. Cool. So we say when a redstone signal is received, evaluate how many items are in the inventory above it in slot 0. Doesn't matter what the item is. And then we log, we send out to the log there the last string. Cool. Okay. So that seems to be working. So when I come over here and I put the program in and we activate the lever, it says 32. Cool. If we take out a certain number of items and activate the lever, it says 16. Nice. So this could really be a button, by the way. That's kind of cool. Okay. Don't mind me checking out a new mod that's pretty nifty. 0. Haha, because there's no items there. Sweet. I like it. Let's play with variables now, because I want to. So I'm going to keep that in there. I'm going to steal this program code. Cool. And we're going to, instead of immediately logging this, what we'll do is put this down here. Well, we'll clear it. Okay. So we're going to find, where's variable? Variable. Operation. So we can move items, by the way, from one storage to another. Operation set variable. Here we go. Cool. So copy the last return value to the specified variable. And we will do variable 1. Does that sound cool? And then I should be able to read the variable. No, wait. I can then just do log message variable 1. Cool. Let's save this and see if it works. So we go over here and we say that you're allowed to use variables 0 and 1. That's what this does. Set up item and variable allocations. So this is a item storage space. So when we move items from one inventory to another, this is like a temporary storage space, I think. And these are the variables. So I'm saying you're allowed to use variable 1. Cool. So if we hit the button, did that just run? I'm going to put 8 in there and hit the button. Doesn't seem to be. It does have 8 in it, so that's cool. That's cool. You can see what's currently stored in there. All right. But when I hit the button, it's not outputting. So if I change this to a... Okay, and this is 4. So that's cool. So what I might need to do is say that you also run on Redstone on. Cool. Is that going to work? Nice. Now if I make that 2, it's updating. No. Interesting. Now it's 2. This should probably say 2 again, correct? And then 32? Okay, so this is executing before this. That's interesting. I wonder what direction this goes. So if I moved this over to here, would that work? Save. So I'm gonna make this 16. Run the program. It still did 32. Now it's gonna do 16. Very interesting. You know what? I bet it goes 1, 2, 3, and this is 1, 2. Okay. So what I could do... This is probably not needed. I was just kind of seeing what happens. So this will probably work. I was just trying to see if I could separate those and how the operation runs, but I'm getting the hang of this. 0, because there's nothing there. 32, nice. And it's storing that 32 in a variable, which I could use later. How cool is that? All right, so here's what I'm gonna try next. I wanna move items around. So what I'm gonna do then is the following, right? Let's say that we wanna move half the items that we get in the slot. So we're gonna take whatever in slot 0, and we're going to do divide integers. Variable 1 will be the last int, and variable 2 will be 2. So whatever's in there divided by 2, that's how many we want to move. And then we're going to store that in a variable. Variable 1. Cool. And then we're going to say fetch items, push items, fetch from storage, push to storage. So fetch items from an external inventory, push items to an external inventory. Cool. So we will say push, so we'll say, let's see, fetch items from an external inventory. Inventory will be up. I don't know why there's 2 of these. I'll have to find that out. And I hear a zombie, so I'm gonna sleep real quick. So we'll say fetch items from the inventory above. Slot will be always slot 0 for now. Item we don't care about. Amount will be variable 1. And slot out will be constant slot 1. Cool. And then we're going to push items. Inventory, I believe east is the direction. Slot, let's say 0. Amount will be variable 1. And slot in, what's slot in? Slot in processor, right? So that'll be 1, because that's what we made this, right? Cool. Slot out, slot in processor. All right, so this, in theory, if I've done this program right, should move half the items in slot 0 into here. Cool. And just for fun, we're going to log variable 1. Cool. So let's save that. Not the prettiest program in the world, but she works. Hopefully. You ready to try it? Push button. So slot 1 is 32. Why you no work? Did I forget something really obvious here? Probably. Okay. So you should push that over to there. That's what we want, right? Because the green is the output. Boom, 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 boom. Yes, that is correct. Save. $16. 16. 16. How cool is that? I like it. I like that a lot. Now if I hit it again, it should move 8. And over here we've got 24. Hit it again, and we've got 4 moved. Hit it again, and 2 moved. Hit it again, and 1 moved. Hit it again, and I don't know what's gonna happen. Okay, it didn't crash the server, so that's good. I guess it just rounded down, but that's cool. Look at that. And it's writing it all out to the console, and it's storing it in the variable. That is pretty slick. I can foresee a great many bits of fun with this. That is really cool. We could do custom things like read the number of items in a slot and emit a redstone signal based on that amount. We could, and this is only version 1 of the mod. There's a lot more stuff coming. Like there's auto crafting coming. There's huge amounts of things that he has planned here. This is really just the beginning, but that is really cool. All right, let's come back in a minute. All right, guys, so we've hit the wrapping up point for the episode, but hopefully this has given you some insight into what RFTools control can allow you to do. So we haven't looked at the storage stuff yet. Also, there is a remote networking piece that basically makes it so that instead of having the inventories adjacent to the program running the processor, you can have them adjacent to some remote nodes and connect to them with a network card. So basically, a remote node would take the place of this processor, and the processor itself would be somewhere else. But you get the gist, so it's cool. I think this is really neat. I definitely like this mod so far. So what I think I'm going to do is wrap up the episode here. We'll come back next time. I want to show this to T-Love. It can obviously hook into RF amounts, so we could do like complex things. Like we could say, oh, and also it doesn't always have to run on a redstone signal. You can have it on repeat, execute a program every so many ticks, or on a signal when a signal is received from an RFTools screen. That's cool. So obvious integration with RFTools. Wire obviously connects opcodes. There's a lot of stuff we can play with here. But I definitely noticed that you can read, what is it, test equality, test greater than, get RF and machine, get max RF and machine. So we could read the RF and we could do like percentage-based stuff. That would be really cool. Definitely some neat things to consider. But for now, like I said, wrapping up point for the episode. So Direwolf20 signing off. Hope you guys enjoyed it. I want to see how auto crafting works with this, because I bet we could eventually build a system that says, hey, if you don't have X number of items, go ahead and craft them, and that would be really cool. Anyway, for now, take it easy.